Hi guys, this is Chem Vid for Molarity, Molality, parts per million, basically your solutions notes. Alright, so in the past we've talked about what a solution is. A solution is when you take a solute and you dissolve it into a solvent. And once you mix those two together, you have created a solution. So as a review, solute is the thing that is dissolved, and a solvent is the thing that is doing the dissolving. Alright, so like with salt water, salt is my solute and water is my solvent. It's dissolving the salt. Alright, so today what we're going to learn about is the three different ways that we're going to talk about for talking about how strong a solution is. Alright, so molarity is something that we use for solutions. Alright. If you remember during one of your labs you had 3 molar HCl and you guys were kind of like wondering, well, what the heck is that? It was a ratio. It was just telling you how strong that HCl was. So let's look. Molarity is a big M. That's its symbol. And molarity is the number of moles of solute all over your liters of solution. So in other words, this is just another way of saying a fraction, right? You're asking how much solute do you have per your total solution. So I'm going to look at my lovely example, and it says that I have 40 grams of C6H12O6, also known as glucose, and I have 1.5 liters of solution. Well, if I look at my equation, moles over liters, so I got to get from grams to moles. So that's 180 grams to 1 mole. Alright. Then I put that in my calculator and it's 0.22 blah 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 moles of sugar. Okay. So if I want to find the molarity of my concentration, I take 0.22 moles of sugar, my solute, over my total solution, which is 1.5 liters, and I get 0.148 moles per liter, or you can write this as big M. Okay, so molarity is just moles per liter, and the units are moles per liter, or you can just write big M. Molarity is a unit in and of itself. Okay, so molarity is one of the ways that we do concentrations. Now the thing that we are going to focus on in class next time is the dilution equations, which we use molarity for. So let's say that you have 12 molar HCl. But for your specific experiment, you need 1,000 milliliters of 3 molar HCl. If you haven't caught on, this is the example problem. So, we have 3 molar HCl, which is a low concentration. We have 12 molar HCl, which is a high concentration. Now, how am I supposed to get from a high to a low? Well, let's think about it in terms of orange juice. If I have orange juice, alright, and I'm mixing it together, I don't know if you guys have used the concentrated kind or not, but you mix orange juice together with water and you get orange juice. But sometimes it can be too strong. It's too tart, too much orange. Alright. So what do you do in order to get the orange juice to be less tart? Well, you add water to it. You just add a little more water. It evens out the ratio a little bit more and you have a weaker orange juice. Well, it is the same for chemicals. If I want to get my high concentration to a low concentration, all I'm going to do is add more water to it, and that will start diluting it. It'll make it weaker. Okay, so now here's the big question. Well, how much water do I add? Like, I have 12 molar HCl here. How much water do I add? That's where you use the equation found on your notes. M1V1 equals M2V2. Alright? So M1V1 equals M2V2. M stands for molarity, and V stands for volume. Now, this guy helps me by saying, okay, so M1V1, that's talking about the concentration I have. So it's talking about my 12 molar. Ooh, I forgot my molar up here. Okay. 12 molar HCl times the volume of my acid, which I don't know. I don't know how much acid I need to put in. So I'm going to leave that as my variable. And then I need 3 molar HCl times 1,000 milliliters. Alright? We go back to some very basic math, some algebra here. I divide by 12 molar and I get my volume to be 250. Okay, here we go. 250 milliliters. Now, I want you guys to pay attention to your units. Units are always important. If you look, this is moles per liter, and this is moles per liter. So, since our moles per liter cancel out, it's cool to have our volume in milliliters. However, you need to make sure your units cancel out, otherwise you're going to have a unit factor on your hands. Alright? So just make sure the moles per liters cancel out and you're left with milliliters. That's how I know how much volume. So I solved this magical equation. Alright? 250 milliliters of volume 1. Well, what the heck does that number mean? So we go back. I'm going to get a new slide. Hold on. So we're going back. I need V1 is equal to 250 milliliters. That number is very special. It has a meaning. It's not like in math class where you just have numbers. These have meaning. This is saying that I need 250 milliliters of my acid, and then when I add my water, that's going to equal 1,000 milliliters. Okay? So this volume, it's not like the final volume you need or the final amount, concentration you need or whatever. It's just a stepping stone in your solution. Alright? So if I have 250 milliliters, I can do some quick math and I can say, oh look, I need 750 milliliters of water. So if I take 250 milliliters of my, where's my thing? 12 molar acid, and I mix it with 750 milliliters of my water, I'm going to have 1,000 milliliters of my 3 molar acid, which is exactly what I want. So when you're making dilutions, it's very important that you keep the addition of acid and water very specific. So we use what's called a volumetric flask, and a volumetric flask, it's kind of like a graduated cylinder, just more precise. And this volumetric flask is 1,000 milliliters. So what this means is when I add liquid up to that line, I'm going to have 1,000 milliliters of whatever is in here. Now here's something that is very, 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 very important. Whenever you are adding acid to water, it is extremely exothermic. You learned that during our thermodynamics lab. When you added the H2SO4 to water, you got an extremely exothermic reaction. However, what you may not know is if you add water to acid, it is a much bigger exothermic reaction, and that reaction can actually break your glassware and cause things to shatter. So, on your notes, make sure you write, whenever adding acid and water together, you put acid into water. You never put water into acid. Okay? Write that down. Know that fact. Very important. We're going to go into acids and bases, and that is extremely important. Alright, so now that I've got that out of the way, I'm going to put some water into the bottom of my volumetric flask so that I'm not adding, so I can add my acid to water and not water to acid. So we're going to put some water in there. Then I'm going to take a graduated cylinder and I'm going to measure out 250 milliliters of water and I'm going to pour that in there. Okay. And then I don't even have to use a graduated cylinder for the rest of my water. because all I have to do is I have to fill up the rest of the container with water all the way up to that lovely little line. And that is 1,000 milliliters total, which is what I want my solution to be. So I'm going to put a little, I guess I should use black. There we go. I'm going to put my lid on top. I'm going to give this a nice friendly shake. Okay, don't be shaking it all over the place. But I'm going to give it a nice shake, mix it all up. And by the time I'm done, I have just created my 3 molar HCl solution. Alright, so as a recap, we used our equation. M1V1 equals M2V2, right over here. We solved for the volume of the acid we needed, V1. That was how much volume of my original or concentrated acid I needed. And then I added water until I got to the desired amount that I wanted, which was 1,000 milliliters. I always add acid to water. I use a volumetric flask to keep it precise, and that's how you make a dilution. Very important. Dilutions. Alright, so now that we got dilutions out of the way, let's talk about molality. Molality is a very similar thing to molarity. It's just a ratio. It tells me how much there is. However, molarity is used for solutions. Okay, it's always used for solutions. And it's moles of solute over liters of total solution. Whereas molality is a ratio. Okay, so molality is a ratio. Molarity is a percentage. Molality is a ratio. Sorry about that. Ratio. And it's saying it's how many moles of solute are there compared to kilograms of solvent. Molarity percentage, molality ratio. Alright. So as I'm looking at this, example number 2, I have 10 grams, 0.0, sig figs, grams of sodium sulfate. Sulfate is 2 minus, so I know I need 2 sodiums. I'm going to put my molar mass on bottom, which is 119.05 grams to moles. And I'm going to calculate that out, and I find out that I have 0.0839 moles of sodium sulfate. Okay, so the molality, I put my moles on top, 0.0839 moles of solute, correct, over kilograms of solvent. Now if I look, it says 1,000 grams. I know 1,000 grams is equal to 1 kilogram, so I'm just going to put 1 kilogram right there. And I get 0.084 molality, or moles per kilogram. Whichever you want to put, you can put little m or moles per kilogram. And that's how you calculate molality. And we'll be using that for our next class. So make sure you know how to use the calculations. But other than that, that's pretty much all we're going to do with it for today. So that's molality, molarity. Those guys are our concentrations for solutions. Now on your notes we have parts per million and types of solution. What I would like you to do is, with parts per million, I want you to try it. There's an equation. Try the example by yourself. The different types of solutions, I want you to read those, understand those different ones. We've talked about homogeneous and heterogeneous before. So the only new ones are saturated, supersaturated, and unsaturated. And I have a feeling you guys can read those and understand those on your own. But we'll talk about that in class if you have any questions. Alright, thank you for watching. And please come to class all ready to do your Kool-Aid lab.